Alright, so let's go through the try yourself one of the momentum notes. Okay, so we have this block X, right, sliding along a horizontal frictionless surface. So when you see a frictionless surface, right, means that there's no external force. So no external force. So meaning that we can actually apply the PCOM, so towards a stationary block. So meaning that the momentum of block Y is actually 0. So there's no resistive forces acting on block X as it moves towards Y. So at time equal to 0, block X has a momentum of 0.4. So after a short time later, right, the block collide and then separate. So we are given the block Y momentum time graph. So let's analyze what is going on, right? So from 0 to maybe 60 seconds, right, they are, the momentum of the block Y is equal to 0. Then after that, right, at 60 to 100, so from this part to this part, right, the block Y actually collide with block X. Because you can see that suddenly there's an increase in momentum. So meaning that the block X actually hit block Y. Okay, after 100 seconds to 160 seconds, so the block Y actually move towards the right hand side with a momentum of roughly 0.5, right? Okay, so the very first part A, so define what is linear momentum, 1 mark. So this is a definition question. So first is the product of mass of an object and the velocity of an object. So of course, remember to write down the direction of momentum is in the same direction as direction of velocity. Because remember, right, momentum itself is a vector quantity. So meaning that, for example, right, if I go back here, so first the block X, right, the momentum is 0.4 towards the right hand side, meaning that block X is also, the velocity is also towards the right hand side. So they must be in the same direction. Okay, so with this, right, let's move on to part B, the calculation. So using the graph, right, to determine what is the change in momentum, meaning the delta P right here of block Y during the collision. Okay, so when you look at this, right, the part B, remember to write down the sign, be it your positive or negative, because they never write down magnitude. But if let's just say they write down, determine the magnitude of the change of momentum, then just give them the number. But if they never write down, you must give them, if there's a negative sign, you must give it to them. So for the change of momentum, let's see what is the change of momentum. So initially, right, the momentum of block Y is 0. So it's not moving. Then after you get collided, at the end of the day, the momentum of block Y will be roughly 0.5. So the delta P is just equal to final momentum. So just put PF. PF for final momentum minus initial momentum. So it's a final momentum. Final momentum itself is 0.5. Initial momentum is 0. So just give them in terms of 0.5 kg meter per second. Right? So that will be the change in momentum. Okay, so for part C, hence determine what is the magnitude of the force, right? So you can see there's a magnitude here. So meaning that you just give them the number. So magnitude of the force exerted by block X on block Y. Okay, let's take a look at how do we actually solve this. So from 60 to 100 seconds, the block X and block Y actually collide. So let's, this is block X, this is block Y. Now, okay, so during the collision, right, apparently, right, block X will exert a force on block Y. So I don't know what's the force, so I want to calculate, right? So what about the block Y? The block Y will exert an equal and opposite force. So this will be right here. So they are actually action and reaction force, right? So these are known as your Newton third law. Alright, so we are asked to calculate what is the force exerted by block X on block Y. So meaning is this thing. Right? Okay, so how do I actually calculate? This is where I need to use the F equal to delta P divided by delta T. Okay, looking at this, right? So delta P, we know delta P is 0.5. Okay, what is the time of contact between X and Y. So the time of contact, right, is from 60 all the way to 100. So this is the time. The time in contact. So just take note of the units, millisecond, right? Meaning that this is 10 to the power of negative 3. Okay, so with this, right, I can actually calculate what is the so-called force that the block X actually exert on block Y. So, okay, I just draw block Y first. Okay, this is block Y. Okay, so next will be the force. So to calculate the force, you must use F equal to delta P divided by delta T. So this is the so-called the Newton's second law that we learned, right, last week. So Newton's second law, so delta P is the so-called change in momentum. So 0.5, what is the time in contact? The time in contact is roughly 40 millisecond, meaning is 40 multiplied by 10 negative 3. So this will actually give me 0.5. Let me just do a quick calculation. 0.5 times 40 negative 3. Okay, so the force exerted is actually 12.5 Newton. So that is how we actually calculate the force. So okay, let's move. Okay, so this is 12.5. Okay, so likewise for this force right here is also 12.5 because they are actually equal and opposite force. So this will be 12.5 Newton. Okay, for part D, we are asked to sketch the momentum time of your block X from time equal to 0 to all the way to 160 millisecond. And of course, the last part is to explain how the momentum of X is determined from part B. Okay, let's do the sketching first. Okay, when we know that before collision, from 0 to 60 seconds, we know that block X has a momentum of roughly 0.4. So let's draw the horizontal line first. So this will be from here. So this this part will be 0.4. So it's horizontal because the momentum is constant. There's no friction, no resistive forces. Okay, so I don't sketch the collision first. I sketch the after the collision. What is the momentum after the collision? So meaning that, for example, right, we must use the PCOM. So initially, right, okay, look at both of these X and Y. The total momentum, so momentum before, so let me just write down. So momentum before collision is equal to momentum after collision. So what is the momentum before collision? The momentum before collision is just 0.4 plus 0. Where's the 0.4? 0.4 is actually right here. So meaning is this one. Then what's the momentum of Y? So this is 0. Then aftermath will be right here. So aftermath, I know, the momentum of Y is actually about 0.5. Right? Okay, let me just write down 0.5. So 0.5. Then what about the X? So I must make sure that left hand side is equal to right hand side, meaning that left hand side is 0.4, right hand side must also be 0.4. So this is your momentum of X. So this X must be 0.1, negative 0.1. Because negative 0.1 plus 0.5 will become 0.4. Meaning that after collision, right, okay, your Y will move towards the right hand side with a momentum of, let's just say, 0.5. Okay, but your X will move towards the left hand side. Because always remember, I say, right, the positive and negative just means direction. Negative just means towards the left hand side. So meaning you will move to the left hand side with a momentum of roughly 0.1. It's towards the left hand side. So you just need to sketch out at around 100 seconds. It's about 0.1, right? So let me just erase this first. Okay, so 0.1 I sketch here. Yep. Okay, so just sketch here. So this is the momentum of X after collision. Okay, so what you need to do during the collision is just to use a ruler, right? You just connect the two lines. So for example, okay, I don't use a ruler right now, but of course on your notes, just use a ruler to connect. So this will be the momentum of X before collision. So this is before collision. This is during collision. And then this will be after collision. Okay, so that is how you actually draw the momentum time graph. Okay, maybe just a side note, if you look at the yellow shaded line, right, and let me just shade one line. So for example, okay, I use a green highlighter to shade, right. So apparently this yellow line, so this yellow line just now we calculated, right? We calculated all the gradient, because remember for momentum time graph, the gradient actually represents the force, or delta P, delta T, right? This yellow shaded region, the gradient, right, is roughly 0.5. Then the green color, right, if you calculate, if you don't believe you can calculate, you will realize that the gradient is roughly negative 0.5. Oh, not 0.5, sorry, it's actually 12.5. Okay, so the gradient is 12.5. This 12.5. Then after that, the gradient of the green color one is negative 12.5. Okay, so we realize that the number is the same. How come the number is the same? Because apparently, right, they are actually Newton's third law. So during collision, so this is X, this is Y. So X and Y, right? So X actually exert a force of 12.5 Newton towards the right hand side. Then for the for the Y on X, right? So Y on X is also 12.5. Just that what is the difference between these two forces is the direction. So this is 12.5, right? The direction actually indicates the the sign. So meaning that this is the negative. So which is consistent with our diagram. So this is negative 12.5 Newton. Then this will be 12.5 Newton. Yeah. So that is how we actually so-called analyze a momentum time graph thing. Okay, so with this, right, okay, before, during, and after collision, right? So let's explain why do we get the thing. Okay, so explain how the momentum of X is determined from part B. Okay, from part B, we realize that we have a change of momentum of 0.5. So always remember, since there's no external forces acting on the system, means that if I say that Y, there's a change of momentum of 0.5, right, means that X, there must be a change of momentum of negative 0.5. So in all, right, when I look at the X and Y as a system as a whole, my total momentum, my change of momentum will be equal to 0. Okay, so let's explain. Okay, so I believe 1 mark is the explanation. 2 marks is for the the drawing of the graph. Okay, so with this, I say that using PCOM, since there's no external resultant force, right? So resultant force, the change, okay, I use this, the change in momentum is of the system is equal to 0. So the system is actually X and Y together. Okay, since the change of momentum of Y is equal to 0.5, right, means that the change of momentum of X must be equal to negative 0.5. So that is how we do the explanation.